Attractor Pattern is a custom feature that I wrote for Onshape that allows you to make patterns that look like this. It can do things that look like that. You can use Attractor Pattern to make things like this, or like that, or even things that look like this. We've even got a little bit of randomness available. So what exactly is going on here? Let me explain. So the attractor pattern, the way it works is it takes a base surface, and in this case, it would be this orange surface, and it takes an input body, an instance. And in this case, that's our hexagon here. And it will pattern that hexagon all over this surface, and then it'll do one more step. It will measure the distance from the center point, or the origin of where that's patterned to, and some set of attractors. And in this case, the attractor could have been this surface, or it could have been these edges that form the outside of this surface. And what it does is measures the distance from each instance to the attractors, and then does some math on whatever that distance is, and uses that number to modify other things. So in this case, the things that we are modifying are the size of the hexagon and how deep they are pressed into the model. And what that gives us in the end here is a very nice, clean transition where it fades from really clear texture to almost no texture and transitions to smooth pretty nicely. So let me walk through a very basic example. I'm going to take you through all of the inputs of the feature, top to bottom, and then we'll go through some real examples and how we might set those things up. Let's get to it. All right, so first we need 3 major inputs for Attractor Pattern. We need a base surface. It could be a sculpted surface on one of your parts. It could be a surface you made just for that purpose. It can be a sketch face. It's very flexible. And then we need an input body, some kind of solid body to pattern. And then we need an attractor. And the attractor can be also just about anything. You can use a whole part as an attractor. You can use just a point. You can use sketches. There's a lot of flexibility there, and it allows us to do some cool stuff. So let's just get all those 3 things made. Shift S to sketch. I'm going to do it on the top plane. Show my origin. I don't really need this to be anywhere in particular. I'll put it over here. So that's going to be our base surface. I find myself often when I'm creating the instances using my primitives custom features. And this time I'll use Prism because it creates a nice example where I'll be able to show off when this thing rotates. If I had a sphere, rotation is not going to show anything. So I like to make the instance some size that's going to be easy to do math on, which is usually 1 millimeter for me, because when we're scaling this thing inside of a Attractor Pattern, we want to know how big it's going to be. And so if I have 1 millimeter times 7, it's a lot easier than guessing what happens if I have 1.375 times 7 kind of thing. Okay, so yeah, that'll be good. We'll just do this as our input. I'm going to taper it. I'm going to taper it to a point too. So we have a pyramid. Let's work with that. Okay, so we have everything we need, and I'm just going to use these edges and things as an attractor. So we'll just use that already. So let's go ahead and call the Attractor Pattern feature. And you're going to be presented with this. That will be open by default. But the structure of this is essentially in the logical order that you're going to want to set these things. So we're going to start with pattern inputs, and then grid parameters, and then instance parameters, and then pattern parameters. And then once you get used to the feature, I find myself kind of jumping around and tweaking things. So I go through and get it like mostly set up, and then I go back and just kind of tweak it until it looks and feels how I want. So let's get to it. Base surface will be that face of the sketch. The input body will be that triangle that we made. And the attractor doesn't really matter. I'll just do this point for now. And as soon as we've got an attractor put in, you see that all of these little parts will show up. There we go. So I've got my pyramids showing up here. With regard to the instances, usually I find myself putting one that I'm going to build in the part studio that I'm going to use it, but you absolutely can have one from another part studio or even a whole other document. And maybe you're going to use this same exact kind of thing across a whole product line and something like that, in which case that's probably how you'd want to do it. So you can uncheck this input from same studio, and then you suddenly get this dialog that you're used to from the derive feature. You can go other documents and find that instance and use it from anywhere. There is an input for a mate connector, and that is if I wanted to have some origin for my instance other than the actual origin. So if I click here on this side face, then these are all turned sideways, and that has become the origin. I don't want that, so I'm going to get rid of it. I also have a flip body, and you can see over here that it's turning them upside down, so it just inverts the coordinate system. But I'm going to leave it as it was. Next, we're going to create our grid. And almost always when I get going, oh, see how I'm still getting the mate connectors popping up? That's because this is still open. I'm just going to click something else, and it'll be a little bit better. When I do the grid, I almost always hit pause regeneration, and that's because I don't need it to actually, every time I change one of these numbers, I don't need it to actually pattern all the parts. It takes a while. Like, it'll slow the feature down, and it's already going to be a slow feature, just fair warning. But we can just preview the points and start to create a grid. So I'm going to just tweak the values for U and V. And these U and V are kind of like X and Y on a Cartesian plane. You have like X, Y, and Z are your directions. And when you have a surface that may or may not be flat, the way you kind of make your way around that surface is using coordinates, but it's U, V, and W instead of X, Y, and Z. So that's why that is the way it is. I'm going to... we have a rectangular pattern here, and you can just do it by eye. We can rotate the grid by whatever amount feels right to us. If we set a border, anything closer to the edge of the surface, then the border will get culled away and disappear. So I'm going to set this back to 0 and that back to 0. And I want to show we have a couple other grid types. We have a triangular grid, which is kind of staggered. You could use that for a brick-like texture or a hexagonal texture or a triangular kind of a texture. And usually if I'm doing something that I want to be hexagonal, for example, I will do it by eye, and I will just look at where these points are. And these already, actually, I did pretty good. These look about right. But it will depend somewhat on the surface. If I change this sketch, then you'll see that the grid, because it's just U and V, it's going to stretch as well. So the grid has also stretched out. So you do have to kind of eyeball it. I'm just going to undo that since I liked where it was. Okay. We also have a random grid, and this will place just, you get to decide how many points you want, and the seed just kind of shuffles the randomness. See how that's getting different every time I change the seed, it shuffles the randomness. All right, I don't use that one a ton, but it's there. I tend to use triangular. So that's it. Our grid is looking good. So I'm going to close this. I'm going to unpause the regeneration, and we should see our triangles show up. And they do. So next, we're going to do our instance parameters. And we're presented with these are the things that we can change about the input body. So let's just go through them top to bottom. Scale. We can make ones that are closer. And remember, this point is our attractor. So things that are close to the attractor are going to take the near value. Things that are the farthest thing from the attractor will take the far value. And everything in between will get whatever values in between. So let's make things closer to the attractor 10 times bigger. So now we're automatically getting this nice fade. And 10's pretty good. Let's see if we can get these to just touch. I mean, again, it's a kind of visual, and you can see that my grid isn't perfect either. So you can play with that as you like. Let's just leave it with that for now. There's also this uniformly option. Right now we're making them just 10 times bigger in all directions, but I can uncheck this, and I could say just be 10 times bigger in the X direction, and these will stretch out. Or I could do X and Y, and they will be the same size that we saw, but they're just going to stay flat, which I kind of like. Let's stick with that. We also can control the depth. And the depth is how far the instances are pressed into or out of the surface. So if I put 10 here, the ones close to this point are going to go down, and we get this kind of ramp effect up to the farthest points over here. Rotation, fairly self-evident what that will do, but one's near, get my near value of 30, and ones far are not rotated at all, and everything in between kind of transitions. And that's how I did things like this one here and this one here are using some of the rotation. But we don't want that today. And then color, realistically, I don't know that it has a practical use, but I think it's fun. I'm going to crank this up so that you can see what the final color really looks like. In fact, I'll just complete it. So the ones near are going to be white by default, and the far ones will be a cyan by default. But if you wanted to change the color to anything you want, you can. We have 3 input modes. We have hexadecimal, which takes values like this. We have red, green, blue, so you can just put in the RGB values if that's a way that you want to specify. Or we have hue, saturation, and luminance, which is another really common way if you've done Photoshop and anything like that. Those will be familiar. I usually use hexadecimal, and one way that I do that is I right-click on any part anywhere and hit Assign Material, and then not material, excuse me, and hit Appearance. I guess it was when I was hitting that vertex it wasn't working. Appearance, that's what we want. So here's the appearance panel. Here's a hexadecimal value of any color we've chosen. So if I pick this color, I get a new hex value. So you can pick like that, copy and paste that in, or go to the mixer, drag it around until it's exactly what you want, and you can grab the hex value there. All right, we don't need the color on this one though. Okay, just to show what's going on with pattern parameters, which is where we're headed next, I'm going to make this more extreme just so you can get a better idea of what's going on. Actually, we'll do that later. Okay, so inside of pattern parameters, this is where we can put in some things that actually manipulate the numbers we're getting. So remember, every single instance is getting a measurement to the attractor, and that's giving us a number that we're working with. And these do some math based on those numbers. So what range will do is let me just show you, and then I'll explain what we're looking at. So I've put in a far range of 150, and that's probably right about here. And anything farther than that range is going to be treated with whatever the far value is of all of our instance parameters. And likewise on the near range, we can set a minimum. So actually we'll pump this up to 100 and makes it clearer what we're looking at. See that? So all these instances here are 50 millimeters, and they were moved. They all have the same near value. And then all of these over here are farther than 150 millimeters, so they get the same far value. And all the ones in between just transition. So without this checked, it's as if our range goes from whatever the smallest thing is to whatever the farthest thing is. The nearest and farthest thing becomes the range, but you can override it with this. Cutoff is kind of similar. It's distance-based, but it'll just get rid of any instances that are farther away than this value. And then fall off is probably the one that I use the most. See how we're getting this kind of line? We got a nice ramp effect going on here, and that's because as we're going away, the distances are increasing in a linear way, so we get this linear kind of a pattern. But we're just working with a big list of numbers here, and we can manipulate those numbers. And so this fall off function will run it through kind of a sine wave function and get this kind of easing in and easing out, which I think is a really nice way to make a pattern that fades out look really nice. It's just a little bit more subtle, feels a little bit more realistic. If you've done any animation or anything, it's kind of like an easing curve. So I tend to check that, and by default, it's going to be 0.5, but it doesn't have to be 0.5. Let me drop this down again, and we'll play with this a little bit. It's just going to be waves, so we can make this thing wavy. So now I put one wave, and from here to here, it's going up and then back down. And so this is where I'm getting all of the far values, but I can put this to 2, and we'll get 2 crests of that wave here and here. We can go up to 5, and you're starting to see that we're getting this like ripples effect coming out from the middle, which can be kind of useful for certain kinds of patterns. It could be interesting. but I don't tend to use it a lot. It is there, and can do some subtle stuff like this. And there's also a decay checkbox. If you've checked fall off, you get a decay, and that just kind of makes the ripples dissipate as they head away from the part. Again, 150 seems to be a good value to see stuff. No, let's go 500. So yeah, the ones near here are the waves are bigger, and then they kind of peter out like that. Let's do 300 and see what we got. So yeah, it's nearly flat here, and then it starts to show up as we get closer to the attractor. So that's kind of interesting. I think that's pretty cool. I tend, again, like I said, just to use this one on 0.5. I think that's my favorite way to go. All right, let's talk a little bit more about attractors. Right. So far, we've just been using a single point, and I just want to point out and reiterate that you can use anything. I can have multiple attractors, so I could have 2 points, and we'll get a very different effect. I could use this whole line, and we'll get a nice clean ramp. Turn off that, just so we can get that ramp effect. I could use a whole body. So I'm going to use my sphere custom feature and put a sphere there and even lift it up a bit. Cool. The sphere can be my attractor. And you see it says face of sphere. That's because this is a part, but it has only one surface. And I could also just pick the sphere from here like that. And this actually says part 2. So if this had, just do it. If this had more going on than just being a sphere, like this, I don't know why, but put that there. This is sort of the same as if I picked this face and that face. Same result. Okay, so that's the basic rundown of the feature itself. Now you know what to click, when, and all of that. But I want to run through a couple of examples just to show some of the ways that I've found to use this thing. And you've already seen the ones down here, but I'm going to show you a couple of other ones. So let's get in here and look at what we've done. For one, I would probably just change the appearance to also be that black color. All right, so here's I remade a model that I had a video of a while back that's no longer up, but this was a paddleboard grip, and this one turned out a little different than the previous, but it'll work. So I've got this texture going on, and I just want to explain a little bit about what we're seeing. So the texture is very dense right here, and it's fading slowly like a large gradient this direction, but it also is fading out as it approaches these edges, and you see it gets very small there. So how did I achieve kind of a dual fade? Well, let's take a look at the inputs here. I started with this. This is the surfaced part, and I have this face that I want to pattern on. But I actually decided to make a duplicate of that face using offset surface with 0 millimeters. And then I used move boundary to pull the edge back away from the crease a little bit, because I didn't want any of those pattern, like the texture bits, to be touching up here. I wanted it to have a little bit of space just on that edge. So I'm actually going to use that as my base surface, not my actual model. As my input body, I used my custom feature called shapes. It can do stuff like this, like stars and polygons and all kinds of stuff. But I'm going to leave it for this kind of 3-sided star, which I then extruded with draft to get that. And I extruded it a little bit in both directions. That way, if it, it's going to go onto a curved surface, and if it was on like a sphere, for example, it would only be touching at one point and it wouldn't be able to merge together. So this gives us a little bit of space to merge with. All right, but the other important thing I did here was create this attractor surface. and it's pulled back from my surface a little bit. And that's how I'm getting my large kind of top to bottom fade going on. So my attractors ended up being this face and these edges. So essentially imagine that you are a little vertex and you're walking along this surface and you're trying to decide what is the closest object to you. If you're right here, it's going to be this edge. But as you travel this way, eventually you get to a point where now this surface kind of takes over, and the attractor is only affected by the nearest, or the objects are only affected by the nearest attractor. So pretty much anything down in the middle is responding to this, but the things that get really close to the edge will be responding to these edges. So that's how I got that kind of compound gradation going. And then last, I want to note that I did not even merge the texture. Inside of Attractor Pattern, we have this make composite part. By default, it's on because otherwise we would end up with, like hundreds of little parts here. Keep inputs just deletes the input instance, which I almost always do delete that. And then you do have all your Boolean options here, and I could hit add, and it will merge with this part, and that will work. But that attractor pattern was coming in at about 2 seconds, just creating all the parts and doing a composite part. And now I'm gonna let this go all the way, and you can see how expensive the Boolean really is with this feature. All right, that took a while. Over a minute. So that is why, unless you absolutely have to, I recommend not merging it with anything. I'm going to switch it back to new. And if I were 3D printing this, which is previously what I did with this, the previous version of this model, you don't actually need them to be merged anyway. You can export this as an STL file and toss it in your slicer, and it'll treat it like one thing. So you can get it to print fine without actually having to merge all the bodies, and that will save you a ton of time on your regeneration and time spent watching that spinning wheel. If I were doing this on a production project, I need to injection mold this or something, then I would merge it, but I would just keep this suppressed almost all the time until the moment that it's like, all right, I'm about to export this and email it, or I'm about to share the link or publish it or whatever. However, this thing is going to leave my hands and get into someone else's hands, then I would unsuppress this and make it work just for that part, and then probably suppress it again because it's just no reason for this to be sitting here bogging down the model. And I'm just going to reiterate that it's not Onshape's fault that this takes forever. We're asking it to do a lot. So just, be mindful if you're going to come in here and put numbers in the hundreds in here. 100 and 100 is going to make a lot of parts, and you're just asking for trouble. So you can, but it's not Onshape's fault if it bogs way down. It's yours. And mine a little bit, tiny bit, but mostly yours. Okay, another example I wanted to show is using a more complicated attractor like this. So I created this surface with the sole purpose of being an attractor to control a pattern underneath. So it touches right here on the edges, and then I've got some indentations and posts sticking out, and that produces a pattern that looks like this. So you can see where it comes down and touches, it's very small. We're getting a lot of the near value here, where I had that really tall kind of post in the middle. We're getting the farthest value, and these are getting the biggest. So you can get some really subtle control over a texture by creating your own input surface. And this doesn't even have to be very complicated. I don't have fillets. It's not very smooth. It's not going to matter too much, especially if you're going to go ahead and check the fall off on that. It helps a little bit to blend it together. So wanted to put that idea in your head. Just you can create a control surface to be your attractor. And just for excessive clarity, hopefully, or perhaps, inside of pattern inputs, my attractors, I chose surface from down here, from this list. If I didn't, then I'm going to be picking faces on this, and that's not going to have the same result. If you mouse if I have other stuff hidden and I mouse right on the edge, maybe I can get it to pick up the surface itself. But it's so much easier to just pick it from right there. And then you're sure you got the right thing. Okay, let's look at another example. I thought this one was kind of cool. And this is an application for that range input. So this is my company logo. And you could do this with your logo or anything that you want. I've got the logo itself as an attractor. I just derived it in, and I'm using those parts as an attractor. I did a move face to make it a little narrower because I'm going to have a little bit of extra space in the range where it's fading out. So I split the difference. I moved face by half of this amount so that it would it's kind of a blur almost, you could think of it. You can see when you get above a certain number of instances, the feature will warn you to just use your head a little bit or just not be mad if it's slow. All right, so what I've done is set up this grid, pretty dense grid because it needs to have enough detail to pick up this texture. And then instance parameters, I'm just changing the scale, and I am using a range. That's what's making this work. If I uncheck range, it'll probably take a while to compute, but it's gonna blur out. You won't be able to make out what we're actually looking at here. I'm gonna hide the logo stuff while we wait. See how you can kind of tell what it is, but it's a lot more crisp if you turn the range on. And then everything, like most of the holes are going to be small, and just a few right around the logo will transition, and all the ones touching the logo are going to be the same size as well. So an interesting application. Another example that does involve using the sine wave is to get some apparent randomness. And so I'm just going to use this as an example. So the way I did this one was the only thing I varied was the rotation, 120 degrees. And here I have, let's see, where are my attractors? There. I have 3 points that are my attractors. And so it creates this really interesting kind of flowing thing going on. But I can use the fall off that we already talked about to create a wave. And if I want these to appear to rotate randomly, I can actually make the number of waves massive, like 10,000. And then the difference between each neighboring part will be on such a different part of the wave that it's effectively going to be randomized. I could do 50,000. It probably won't be that much different. So we can get something that looks like random rotations, and you could do the same with height to get random-ish looking height. As long as your attractors are in also somewhat of an arbitrary location and not, if it was this edge, then, well, let me just show you what will happen. Get rid of these attractors, and we'll use this edge. So all the ones that are in the same row will get the same value because the wave is going super quick up and down like this. So the attractor itself also needs to be kind of arbitrary, not aligned to the grid in some way. But it's an interesting effect that you can get. And one final thing I wanted to touch on is, so far we've only applied attractor pattern to single surfaces. And most of the time, often, I suppose, if you're using this as a grip texture or something like that, you don't have a single clean surface that you're working with. So I want to show you how you can achieve something like this on a surface that is definitely made up of multiple faces. Like this. So we've got all of these different faces, and we can't click a certain single thing to do the attractor pattern. This is part of the reason that I made this other feature called Drape Surface. I have a really in-depth video about that I'll link to on the screen, but that is how I'm doing this. So let me just go through that quickly. I'm not going to go exhaustively through that feature because I already covered that in another video. But to do it for this one, I made this arc shape that touches over here and just barely comes up over the top. Good enough. I think that's fine. And then inside of Drape Surface, I'm using this tool to project that surface onto this body. See that? So it produces this grid, and it's actually lofting through all these edges, and it's just close enough to work. because we really don't care too much about the surface quality. I mean, it'd be great, but it's not going to kill us. So we're kind of shrink wrapping this onto that a little bit. And I do want to show one thing though with this. If I hit Shift C, it will turn on the curvature combs for this surface, and that is just a hairball. We can't tell what's going on. But if I drag this all the way down, we can just see the grid. And there's a couple of modes you can use to create these surfaces, and Loft was giving me the best grid. So you need to always be aware of the grid that you are giving Attractor Pattern. The base surface really is nothing except for just a grid for it to use. Remember the U, V, and W coordinates. So if I have a different grid, if I use constrained surface instead of Loft, you can see how the grid flares out here, and our Attractor Pattern is going to follow that. So I tried them all, and I found that Loft gave me the result that I wanted. So now I just use that surface that Attractor Pattern, or that Drape Surface put out for us as my base, and the rest is pretty basic. We've already covered it. So there you go. I wanted to write this feature as a way to somewhat democratize patterns like this that you'd otherwise need to dig in with Grasshopper and Rhino or some other program that can be really tough to learn, and for many designers and engineers is just a non-starter because it's not quite worth it. But if you could do patterns like this in your native tool, then maybe you would. So I've got some background in Grasshopper and Rhino, but I thought that the ability to do this in my native CAD tool without having to leave and break the parametricity of my model and all of that was really worth it. And as a bonus, it makes this kind of patterning available in a way that wasn't before. So if you end up using it, let me know. Also, let me know what questions you have. Like and subscribe really helps me out. That's all I got. Thank you for watching.